You're listening to the Chorus One podcast, a show that covers decentralized networks and their impact on the evolution of automated and borderless economies. On this podcast, we invite pioneers and builders to discuss the decentralized protocols and projects they are working on. On the show today, we have Arjun Bhuptani, founder of Connext. Connext is an interoperability network which is going to market with NXTP, a non-custodial cross-chain protocol. Connext is trustless, meaning there is no trust placed in external validators outside two native blockchains where a cross-chain transaction is occurring. Connext makes use of routers, which are nodes that facilitate cross-chain transfers and hold liquidity of different assets on multiple chains. If a user wants to move from chain A to chain B, they would signal their desired route to Connext's network. Connext then broadcasts a user's desired route across chains for routers to submit the best price they can give the user, like Uber. A user would then receive the cheapest route possible to transfer their assets across chains from routers that have the most available liquidity and most competitive fees. We talked to Arjun about the trustlessness nature of Connext, how it locally verifies transactions versus other possible models, how routers facilitate transfers, the intricate economics of Connext, how Connext ecosystem actors interact with each other, plus so much more.
Hello to another Chorus One podcast episode. Today with Arjun Bhuptani. I hope I pronounced it halfway right. Of Connext, and welcome to the show.
Thanks so much. Thanks for having me, guys.
Yeah, so we're really excited. Like, one of the core topics for us is interoperability. That's, of course, the space where Connext is in. So maybe we can get right in and talk a little bit about Connext and also the new protocol you launched called NXTP. So maybe the first question would be, what is Connext and what is NXTP?
Yeah, good start. Connext is an interoperability network. Our goal is, our kind of overarching vision is that we're sort of headed towards this very heterogeneous mix of chains, both within the Ethereum ecosystem and then also more broadly within crypto. We see this happening because there's several reasons. One is, like, from an infrastructure standpoint, from a decentralization standpoint, it makes sense to have like a diversity of different types of solutions, like chains, L2s, things like that, to allow for like different types of scaling and to push push different like new types of use cases that you wouldn't be able to have otherwise. But then in addition to that, the other reason is also just because people hate adopting standards, and they people will sometimes go and choose a different type of network, a different type of solution, if only because they want to be contrarian. Now, our kind of overarching vision is that we think that there's a need for a protocol or a set of protocols that connects all of these different kinds of systems together, and a big challenge is how to do that when they're all very different from one another. Connext right now is this like broader network that will enable this type of connectivity between different chains and L2s. And then NXTP is sort of our first like base layer protocol. You could kind of think of it like TCP/IP. It's a base layer protocol that allows you to do like the most simple kind of connection, which is like cross-chain transfers and contract calls. And that connection can eventually be upgraded to like more sophisticated kinds of communication between chains, depending on what other infrastructure is available and what chains you're communicating with.
Yeah, it's a fantastic intro. Thanks for that, Arjun. And when we first met each other, maybe 6 or 7 months ago, you were still building out Connext and it was in its early stages. So I think what might be very interesting for listeners in general, especially maybe those who aren't as familiar with Ethereum, for example, is perhaps your personal journey in Ethereum, because you've been building sort of layer 2 sorts of solutions for many years now, and you're one of the OGs, I think. So how has Connext evolved since when you started getting into the Ethereum ecosystem to what it is today?
Yeah, so I first joined the Ethereum ecosystem in 2016. It was like immediately after the DAO hack. Very inauspicious time to join the space. I became really interested in it because at the time I was really interested in this like broader idea of being able to like work for the internet. So like not necessarily having a job or a like workplace that you're earning from, but being able to like work for like one of several different things and having like several income streams. To me, that seems like a much more kind of like almost like a much more fault tolerant way to do work, where like if one of your work streams dies or stops working, or like, you know, they fire you or whatever for whatever reason you stop working with one project, you still have like other income streams, and that's not like the only thing that you're doing with your life. I became interested in Ethereum because I kind of like saw that this is something that could actually happen in this space. Like people could eventually get to the point where they're working for a bunch of different protocols. They're either like contributing passively to the protocols by contributing infrastructure or liquidity, or they're actively participating in communities and governance and things like that, and kind of like working part-time. It's kind of cool because that's actually starting to happen now. Like I know a few people that actually work this way. They've quit their day jobs and they actually just have like several different protocols that they're contributing to, and like that's how they make a living. We started Connext about a year after I joined the space because at the time, like I was kind of really interested in finding ways I was starting to see this happen where people were earning based on Ethereum, but what we saw is that there's this like big disconnect between like what, you know, crypto natives were able to do and like what the broader ecosystem of people outside of crypto were able to do. And so we started Connext because we were really interested in figuring out like this user experience problem of like, how can you let users interact with crypto, interact with blockchains without them needing to have to like learn everything about these different chains. As you mentioned, we were like one of the first projects in the space. It was really, really cool to see. We started out kind of doing more on like the R&D side. We were doing a lot of like early layer 2 and scalability research. We actually built one of the first ever layer 2s in the space in partnership with SpankChain. It was a payment channel hub. SpankChain was actually one of the only projects at the time that had any traction at all. And they needed scalability. Like they actually had like users, and their users were like, hey, like I want to be able to tip $1 and I can't do that. It's too expensive. So it was just pretty cool to see and to be involved in that in the earliest days of Ethereum. One thing that we kind of saw was that there was this like push within the scalability space towards rollups and towards like moving to kind of other chain-like environments. And that's when we started to think like, okay, well, what happens when that happens? Like, what is the kind of ultimate, outcome when you have, Ethereum 2 and like multiple shards and like all of these rollups? Like, how do you actually navigate this as a user? And kind of going back to our original philosophy around like user experience, making this seamless. Our thinking was just like, okay, well, users really don't want to care about what shard they're on. Like they're not really going to give a shit what rollup they're on. Obviously, like right now there's tribalism. Obviously, right now people are like, okay, well, I like Arbitrum, I like Optimism, I like zk Sync, whatever. But we really think eventually it's going to get to the point where people are like, okay, well, really what I want to do is I want to use XYZ application. Like I want to use SushiSwap and I want to just like source the best liquidity from whatever. I don't really care what rollup I'm on. I just want to use the app. In the same way that like today we just go and use, YouTube, and you don't really think about the fact that YouTube is actually like, a sharded distributed database that is like clustered over many server stacks that are running all over the world. And like distributed via CDNs that are running all over the world. Like you don't actively think about any of that because you don't have to.
Right. Awesome. Yeah, I think, right. So Connext is this bridge between these different layer 2s on Ethereum. And of course, there are already other bridges also right now that exist. And of course, one of the things that maybe are interesting in these bridges is, right, like for one, the cost to make a transfer between the two networks and the time it takes for the transactions to go through. So maybe you can explain a little bit, how Connext or like NXTP specifically like works on these two dimensions. Like how does it improve? How great does it do? And how does it do that?
Yeah, absolutely. So there's a bunch of different like kind of optionality that you have around these bridges, and like different bridges, different approaches take different trade-offs. So in general, cost and speed is like one of the pieces of optionality. So, obviously you have things like rollup bridges. Those are maximally trustless. Those are kind of like native to how the rollups work themselves. And like we all kind of know at this point that like, with the rollup bridges, you like exiting those things is going to take like a week, and that's hugely problematic for user experience. We also see kind of the same thing with like existing like bridges that are baked into chain. So like the Polygon POS bridge takes 3 hours to get out of Polygon, like half an hour to 45 minutes to get into Polygon, which is also just a huge pain. That said, I would say that for the most part, with like a lot of the bridges that are live today and that have kind of gone to market recently, like you'll find that the cost maybe it's sort of like within the same region, but generally speaking, it'll be, I think generally speaking, NXTP is the cheapest. But like generally, it's also like kind of within the same range. And you'll also find that the latency of these bridges is within the same range, and that's I think because like we've all kind of focused on latency, and we've hit this like lower limit, which is basically how many blocks do you have to wait, like to confirm a transaction, because some of these chains are just like reorging a lot. So like Polygon, for instance, we wait like 80 blocks. I know Seller waits 80 blocks. I know like Hop waits 80 blocks, and the reason is just that like a few weeks ago we saw like a 65 block reorg on Polygon, and so like there's no way for us to really like go any lower than that, because you have to wait that long for the economic security. Now there are a couple of other things that are trade-offs that people have taken, and the three that I think that are really like important in the space, and we just wrote about this, are trustlessness, extensibility. So like how easy is it to take this bridge and like deploy it on a bunch of other chains, and then generalizability. So like what kind of functionality can you enable through the bridge? Like, is it just simple transfers and contract calls, or can you do more complex things like NFTs, enabling generalized message passing? And what we've seen is like, this is kind of more on the research side, but what we've seen is that there's a bit of a trilemma between these things. Like you can really only have two of them, because the different approaches to trying to enable interoperability have to kind of like trade off one of these things against the other. So like, you have like rollup bridges, which are very purpose built between a rollup and a chain. Those are maximally trustless. Those are maximally generalized, but you can't really like take that rollup bridge and then also apply it to like another rollup or another chain. Like it's kind of stuck between Ethereum L1 and a given rollup. And the same core concept applies, when you think of like, okay, well, what about, MPC bridges, things like Uniswap, things like Thorchain. And you when you start looking into those, you realize, okay, well, actually, these things are great because you can deploy them anywhere. They're really, really generalized. But the trade-off is that now you're trusting some MPC nodes, and those MPC nodes have like 100% capacity and ability to rug the entire network. And those MPC nodes are by definition going to be less secure than like the Ethereum validator set, or like even like any other validator set of any other layer one. So we as a project, I think that's kind of where like a lot of these different bridges are differentiating, is like which trade-off they pick there. And like we as a project have kind of picked the trade-off where we're like, okay, you know what, we really think trustlessness is very important, especially within the like layer 2 ecosystem. People want trustless solutions. We also think extensibility is important because it's so, the space is so heterogeneous. We want to be able to bring Connext everywhere. We think it's like very critical that you do that. But we've traded off generalizability. We can't do like NFT transfers through Connext. You can't do like more kind of arbitrary data passing where the data is just like some event data, right? Like you can't do like, okay, prove that on XYZ chain, the TVL of Uniswap is a certain amount of money. Trustlessly between chains using Connext at the moment. Sorry, go ahead.
No. If you can finish off there,
I was just going to say that at the moment that we've found that trade-off is okay for most users and most use cases.
No, so I think just for anyone listening, it's a great article to check out. It's called the Interoperability Trilemma, and I think the three things you mentioned there is extensibility, if it's generalizable, and if it's trustless, basically. Mm-hmm. And so we've spoken a bit about the trade-offs here, but I think maybe we could go back a little bit just for anyone who's a little bit unsure exactly how Connext is trustless and also extensible. So you also mentioned like some MPC bridges. So for those listening, that's like a multi-party computation bridge. That's also worth giving research. So we're going like quite deep here. So I guess for now, Connext's solution, which is the NXTP, so to be trustless and to be extensible, so in MPC style solutions, like you said, the validator set is different to the underlying chain, basically. So maybe it'd be great to hear your sort of view or your explanation of how you don't rely on this external validator set like an MPC bridge might do, and what exactly is Connext, and are the validator sets in Connext itself?
So maybe, and you're totally right. I jumped headfirst into that. Maybe I should like take a step back and explain what we mean by all of this too. So I think something that's really important to think about is like who is verifying a given transfer across chains, right? And that's like what generally when we talk about validator sets, that's like what we mean is like who are the people that are saying, okay, well, there were funds here and now they need to be moved here. And there's kind of three like overarching approaches. One is you use the chain's own validator set. So like the people that are running the blockchains are the ones that are verifying something that goes across chains. And what that means, the only way to really do that is like you run some sort of mechanism within the VM of the chain, so within the EVM or anything like that. And that forces every single validator, every single Ethereum node, or at least every single like Ethereum block proposer to like take a look at like what is going on and figure out, okay, does this match with what is happening on a different chain? So we call those kinds of systems natively verified. So basically, those are things like a rollup bridge. Those are things like IBC in the Cosmos ecosystem. The near Rainbow Bridge is a great example of this as well, where what you're basically doing is running a light client of one chain or one rollup inside of another chain or rollup, and they're able to like talk to each other natively. The second approach is, the validator set is different from the validator set of the chain. So you have some external set of parties that are deciding, okay, I'm going to like watch both of these chains and I'm going to port funds from one chain to another. And the model here is like similar to like an Oracle or like a multi-sig or something like that, where you have like a group of people that are saying, we're the ones that are responsible for porting the data around. And like, if something goes wrong, we're the ones that are liable. Now, of course, you can build like, insurance mechanisms and things like that, but like you have to, in order for it to be trustless, you need to make sure that the amount that is being insured, the amount of insurance that these guys have is equal to or greater than the amount of money that they're actually moving between chains. That's almost never the case because that would just be really capital inefficient. And so generally speaking, with these kinds of systems where you have an external validator set, you're kind of trusting that validator set. Now, maybe in some cases that's okay, but it is important to remember that that is always going to be strictly less security than like, just Ethereum itself. And then the last one, and this one's a bit different than the other two approaches. Like it's either you have the same validator set, you have a different validator set, or you have the third option, which is you have no validator set. You don't really have any group of people that's like responsible for porting data between these chains, because the data that you're not really porting data between chains anymore. What you're basically saying is, okay, well, do I really need to change the global state of the chain? And in some cases, you kind of don't, because what you can do is you can say, okay, well, I'm just going to pick some counterparty. It's me and somebody else, and like the two of us are going to just swap with each other. And because all we've done is like change our own state relative to each other, the rest of the chain doesn't really need to care about that. And so like you don't need anybody else to validate this interaction that we've done between the two of us. You can just have us two people verify each other, make sure that the other person is not cheating. And as long as the two of us are able to kind of like contain that, like basically contain the activity in a way where like none of it leaks to the rest of the chain, that is actually a perfectly acceptable way to do interoperability. So examples of this are things like atomic swaps. It's like the quintessential example that people have been talking about for like almost a decade now. And in an atomic swap, what you're doing is you're taking a counterparty's funds, you're taking your funds, and then you're just like swapping them for each other. And because you're doing that, like from the perspective of the rest of the chain and the rest of the chain's nodes, they're just like, yeah, like nothing has really changed there. You just exchange with each other, and as long as you both are okay with it, it doesn't matter to us. Yeah.
And so this like sort of swaps, let's say, so it's sort of localized and isolated in a way, so it doesn't affect the chains overall, which is a really interesting way of doing interoperability. So we've had a few people on our show recently doing other styles of interoperability, and this is definitely something that's very unique about Connext, what you just explained. So now it might be a good time. So Chorus One as a validator, so we're a partner with Connext. So we'll also be running our own routers, they're called, in your system. It would be fantastic, I think, if you don't mind explaining who's actually the intermediary. Let's say if there's two counterparties, do they go directly to each other? Is there an intermediary that they use to keep it fair? What are these actors in Connext?
Yeah, absolutely. So one of the big kind of like limitations of traditional atomic swap models and things like that is like you have to find a counterparty, right? And like there's like how do you really do that? And like traditionally the way that people think about that is like, okay, well there's an order book and like you have to find somebody on the order book and both of you have to be online and then like you have to swap against each other. But we've learned from DEXs, we've learned from like AMMs and things like that, that order books just don't work in this ecosystem. People don't like that kind of liveness, and like you do get like better pricing in an order book model, but like people really don't care about that as much as they care about just like the convenience of being able to interact with the chain whenever they want and however they want. And so we kind of like rethought how like atomic swaps and how this kind of like one-to-one interaction works from first principles. And we said, well, why, fine, you may not necessarily be able to trade against a contract or something like that, but what if you're just trading against a network of liquidity providers in the same way that you're trading against like an ecosystem of liquidity providers on Uniswap? And that's where this idea of like routers came from. It's like routers are basically the infrastructure providers within Connext. They submit transactions to chains. They actually submit each other's transactions to chains. And also do it on behalf of users in certain cases, because we kind of use like a meta transaction pattern. And then the other thing that they do is in a given instance, if they have some liquidity, they can also be the counterparty for a user. They can basically facilitate the transfer across chains and make sure, if there is like a contract call or something that has to happen in addition to that, they can also execute that piece of a user's transaction. So that's really interesting, because it's like you have this like ecosystem of LPs, and for now they're providing their own liquidity, though there are ways to have them like kind of have passive liquidity provision as well. And when a user goes and says, I want to go and transact through Connext network, what the user is basically doing is like almost like an Uber style auction situation, where they're just like broadcasting the network saying, hey, I want to go from A to B. What is the cheapest and fastest I can get there? And exactly the same as Uber, Uber kind of like broadcasts that to the network of drivers. The network, it like kind of figures out who are the drivers in your area, how much are they going to charge you to get from point A to point B, and then it'll pair you with the cheapest driver. In the exact same way, like the user is like broadcasting the network, they get bids from all of the routers that are willing to supply that liquidity, and then the user themselves picks, the cheapest bid. Or we don't explicitly pick the cheapest bid. We actually do like the cheapest X percentage, and then do like a weighted random select, and that's just to like stop gameability. But like in general, like as a user, you're going to continuously get matched with the cheapest routes, and the cheapest routes are going to continuously be the places where there's the most available liquidity, or like the best kind of options for capital and for your transaction to get completed.
If you're saying we there, is that like the Connext network or the client, or who like does that selection?
Yeah, and it's cool because it's like we wanted to make it as decentralized as possible. We didn't want to have like with any kind of auctions. What makes auctions centralized is when you have an auctioneer, right? You have some person that is responsible for like managing this auction between different parties. And so what we did was we said, okay, well, we don't want to have an auctioneer because we don't want to run any infrastructure. We're like an open network, an open protocol. Ideally, this is happening either client side or router side and nothing else. What's cool in this case is that the user is the auctioneer. The user is actually the one that is, it's like a reverse auction. The user is the one that is broadcasting to everybody saying, you bid to me, and like I will be the one that chooses the cheapest bid. And so all of this is happening in the user's client. It's happening either on the front end or it's happening like in the back end, wherever a user is running their like Connext SDK.
Now that's definitely very, very cool how you reverse engineered that. So I think it might be a cool time now to ask, so what are you live with? So if I'm a user right now and I want to use Connext, what sort of networks are you connecting at the moment? And let's also maybe a follow-up question to that is on the flip side, these routers, can routers also be on any network, or is there a certain number of routers that you've gone live with, sort of the fundamentals of what Connext is now maybe, and how you could see it developing in the future?
Yeah, absolutely. So right now we are live with Polygon, Arbitrum, XDAI, Phantom, and BSC. We are also going live with Avalanche today. I can say that because I know that this won't air until a few days from now. We're probably going to. I mean, we're also like expecting to add support for Ethereum and Optimism within the next like couple of weeks. It's pretty quick. We're literally just like it's spaced out more in this case because of like BD and marketing than like the technology. It's actually very easy for us to add new changes. It's really cool. We will probably add support for anything that's EVM compatible. So we're already in conversations with like Celo, Moonbeam, Moonriver, like Aurora, I think there's like a Solana one that is coming out, a Solana EVM compatible chain. There's like, Fuse, there's Harmony, I think EVM compatibility is now becoming the default. Like, people are realizing that there's no real way to get around the fact that like Ethereum, for better or for worse, the EVM has like the best developer ecosystem. And so I think we've just like bet very hard on things becoming EVM compatible, and right now it's kind of paying off pretty well. You were asking about the routers. So at the moment, we went live last week. So at the moment, we've kind of limited it to our own router only. Our own router supports all of these chains. However, we are in the process of like rolling out a router pilot program. We basically have 20 or so routers that we've been like speaking to. It's actually 30 plus routers that we've been speaking to a lot over the course of the last few months. Folks like Course One who are like partnered with us that we think are like great examples of stakeholders and like individuals like or organizations that are used to running infrastructure, that have access to liquidity, and that are very, very good early partners for a network that is primarily an infrastructure network. We are planning on rolling out this pilot program over the course of the next few weeks. And at the moment, we have about $1 million in liquidity in the system. We'll probably scale that up to about $20 to $25 million. We actually think that's a lot more than people realize. So most of these other networks, they'll have they'll have $20, $30 million in liquidity, but they're doing $20 million in weekly volume. In our case, we have $1.3 million in liquidity right now, and we're doing $20 million in weekly volume. So when we scale up to 20 to 25 million, that's going to be $300-400 million in volume that we can do of headroom that we have to grow, which is awesome. It's a very capital efficient system, which is really cool. And that, of course, translates to really good returns for routers as well. And yeah.
Maybe we can talk about that, right? Exactly the economics of running a router and yeah.
Yeah, absolutely. And then I guess there was one other thing that you wanted to ask. Oh yeah. So what is basically how does supporting chains work for a router? We've tried to keep it as flexible as possible. So as a router, you basically get to choose what assets you want to support and what chains you want to support. And adding support for new assets is literally just adding a line item config in your line item, basically just the addresses in your config. There's just a mapping of addresses based on each chain, and then the same goes for chains. So we literally just take in a set of providers keyed by chain ID, and if you have providers for that chain ID, you're now supporting that chain. It's as simple as that. So if you're a router and you want to add support for new chains, all you really have to do is just find RPCs for it. Which is kind of nice. And we have a bunch of people in our ecosystem that are running RPCs, or a bunch of recommendations based on our own experiences of what are good RPCs to use for a given chain. Yeah.
No, I think thanks so much for that explanation. I think for people like Chorus One and amongst many others, and one of the great things as well about Connext as well is that it's quite permissionless. At least over some time you'll have most of this fully decentralized, so anyone can come in and run their own router. And obviously, the more competitive it is, the better prices that users can get with their transactions. And so, actually, Felix just asked it momentarily ago, but so the economics of these routers, and for example, the fees that are being charged. So you said a bit earlier, it's almost like a reverse auction. So these fees, are they something that routers would charge themselves, or do you get, say, more fees on sort of trade pairs that have more volume, or sort of the economic aspect of Connext?
Yeah. So the way that we've done some modeling and simulation around this, and what we've generally seen is that there's a few things that contribute to the economics. The first is, of course, how used is this pathway? So if you're talking about the Arbitrum to Optimism USDC pathway, probably going to be extremely well used, right? And because of that, depending on, of course, it'll come down to the competitiveness. So depending on how much liquidity is already available there, how many people are already servicing that route, you may get an incredible rate, or you may not get an incredible rate. If there are hundreds of routers pointing to that specific route. So I think in that aspect, it basically comes down to finding routes that are well used, that are not very liquid yet, is obviously the most lucrative way to earn returns in this space. The other thing to remember is that So one of the things that we're going to be doing is like we price liquidity along an AMM curve. So it's actually kind of cool because there's no like AMM deployed on chain or anything, but because it's priced along an AMM curve, we call this like a virtual AMM. Because it's priced along an AMM curve, like the behavior of these things and like the economics of these things will mirror the behavior and economics of things like Curve, like basically stable swap AMMs. And as a user, like you're basically like paying more if you're going to a place that is less liquid, and paying less if you're going to a place that's more liquid. In fact, you may actually be paid to transfer to a chain if there is a lot of liquidity on that chain, and it needs to be rebalanced. So there's a really cool pattern cycle there for users. But what makes this really interesting is the combination of this like AMM math with the auction math. Now, because the auction mechanism, because users are consistently choosing the cheapest prices that they can get in the network, and because the cheapest prices, in some cases, prices where like you're actually being paid to transfer, those prices are going to come from the most unbalanced routers. You are actually the network will actually continuously kind of be rebalancing itself. You'll have, of course, like a space for arbitragers and stuff like that. But if like say like a ton of people have transferred from Arbitrum to Polygon on one specific router, so that router is now extremely unbalanced for Arbitrum to Polygon. That means anytime a single user in the entire ecosystem now wants to transfer from Polygon to Arbitrum, that router is going to be able to offer the best pricing compared to anybody else in the space. So like it actually kind of like levels out the liquidity of all of these things against each other. And the other cool thing is we can actually mathematically show that because the slippage matters, you actually want to run a router that has like a little bit of slippage, but not a lot of slippage, because that little bit of slippage means you're going to get picked more often in the auctions. But having a lot of it means that like users are going to get like high slippage, and so they're not going to get matched with you as often. And what you can show is like mathematically in simulations, we've been able to show that the routers that earn the best returns are actually the mid-sized ones. So you could if you think of like all of the routers in that like based on size, and you plot them all based on size, the APYs kind of look like a bell curve. And that's really important, because what that means is that the network actually has economics that favor decentralization over time. If you run a router that has $100 million in it, and everybody else in the network is running a router that has $5 million in it, you're actually going to earn only like 2, 3, 4% APY compared to the routers that are $5 million earning 10, 15, 20, 30% APYs, which is pretty cool.
That's pretty cool for sure. I mean, I'm wondering, so as a router operator, if my router is unbalanced, basically this will probably be done by the users, like rebalance, or should I do something myself? Can I rebalance it myself? Is this like beneficial for me as a router, or am I really just like running the nodes, putting the initial liquidity there, and then it's all?
Yeah, that's a good question. I mean, there is an argument to be made for you to. So we wanted to make it like as optionally passive as possible, right? So like if you don't want to rebalance it, you don't have to, because there is an economic incentive to rebalance. So, and like we've seen from Uniswap and other ecosystems that like there is a market of mercenary arbitragers out there. And like they're very shadowy, and nobody knows exactly who they are, but they're watching, and they're like monitoring all of these different opportunities, and they are rebalancing them, and they're making a shit ton of money from doing it. Now, of course, like if it's your own router, like you might actually have that data before anybody else does. So if you wanted to be an active participant, if you wanted to like actively rebalance your own router, the fact that this AMM curve math exists means that you can rebalance your own router and like actually basically earn arbitrage and earn a return from that as well if you wanted to. So there are both options on the table.
So I think this naturally sort of alludes to a topic in general, and one thing that I've thought about Connext over the past few months. So some of this, let's say like the routers you just said, they might have information first before other people, and you've also just mentioned Uniswap as well, which is like a typical place that people arbitragers come into. So on Ethereum right now you have miners, but in Connext you have like lots and lots of mini miners who are called routers basically, and not obviously doing the same thing. But they're getting information before other people get it. So there's this similar sort of actors where you have like arbitragers looking for good opportunities, which is like called searches sometimes in these dexes. Then you have like people with their own liquidity, let's say nodes, and you also have like these nodes in Ethereum, for example. So is there like information asymmetry here by any party in terms of like information coming in? Like a router might have information for someone else. Is it like sort of like a war between like a router, like an arbitrager, liquidity provider? Like the system seems so efficient I'm just wondering like if it can be in any way sort of like
gamed, yeah,
get an advantage over another person.
Yeah, I think there are absolutely instances where routers will have certain kinds of information before the rest of the market does. And that just may be because routers are like privy to auction information, right? So they will get like very strong demand signals. So if all of a sudden, like something that we've been talking about internally is like maybe we need to create like a visualization dashboard that shows like where is liquidity actually moving? Because based on like the farm of the day, you actually see, we see in our own router, like liquidity moves from like this chain to this chain to this chain to this chain. And like, we see that like, okay, well, Arbitrum now has this like kick-ass farm on it. And so now everybody has moved all of their Polygon funds to Arbitrum. And we could see that like in our own liquidity. I think routers actually get an even earlier view of those kinds of things because like they're privy to like the auction data, and the auction data is more like demand-driven signaling data that hasn't actually been acted on yet, and so like that happens before anything even goes to chain. However, I will say that like while like routers have access to that kind of data and they might be able to capitalize on it, they might be able to like front run in some cases. The transactions themselves for a given cross-chain transfer are not front runnable. They're front runnable, but they're not subject to MEV. And the reason for that is that like the price and counterparty pieces are negotiated off-chain in the auction, and those come from like basically like those are wrapped up in like a signed bid, and like when it's put on chain, it's already all been finalized. So there's no way for like the big issue with MEV is always like there's some way for some miner to come and front run a transaction because it's basically whoever submits the transaction first is the person who gets this payout. But in this case, there is an explicit counterparty, and so there's no way for some third party to come and submit the transaction first, which is kind of nice.
Okay, I see what you're saying. You're saying it's more of like a one-on-one relationship rather than like everyone outbidding each other for this one miner that includes them in a block. There's more miners, let's say, but they're routers in this case.
Exactly.
But I think
so that's something that we actually do that's explicitly different than systems like Hop, for instance. Like Hop bonders explicitly it's like an open system. So anybody, if a user starts to send a transaction through Hop, like any bonder in the entire ecosystem is able to submit a transaction to like kind of fulfill that liquidity, which means that actually miners could front run it. So the theory is that like whatever fees are being charged by the Hop bonders, like miners could actually theoretically always just continuously front run it until those fees are competed away to almost nothing.
I think, I remember reading an article actually on that recently, which is also something I'll link in the show notes about the differences between, I think it might be in your docs actually. But I think super relevant topic. I think you've explained something that a lot of people I think will be listening into in terms of like this new era that you're ushering in terms of layer 2 liquidity and just liquidity wars overall in Ethereum. I think you're making the whole system much more competitive, which will be more efficient overall. I might have one more question for you in terms of like the analytics. Like you mentioned that you might make a dashboard, or like maybe in terms of, I don't know if you have a foundation or something like that. So are you, I guess like the next step for Connext, are you expecting people to build on top? So for example, I remember reading an article recently where like, and we'll take you back to the start of the podcast where you're like, it's not very, standardized, let's say, where you can go like, or generalizable, sorry, where you can go sort of, anything at any time. But then you also said that you provide an SDK so people can actually build a more generalizable framework, let's say. So I guess what do you expect people to build on top of Connext, and what, or maybe like what excites you about what can be built?
Yeah, absolutely. So I think like when people look back at this, where like interoperability is right now, like, and I've mentioned this on Twitter as well, but I think when people look back at where interoperability is right now, they're going to look at like bridging interfaces the way that we think about email, where it's like, yes, this is like an important first use case of the internet, but it's not actually like the internet, right? This is not the only thing that the internet encompasses. And like in the early days of the internet, that's what people thought it was. People were like, okay, it's web pages and email, and that's really what it is. And like that's the huge innovation, is that we no longer have to send paper around. And it's true that it is like bridging, being able to bridge between chains is really powerful. Being able to do it cheaply and quickly is powerful. But I think what a lot of people are missing is that like we're not like, our goal is not to build this like bridge UI. Xpollinate is of course like this first step in this direction, but it's not like our ultimate vision is like we really think that like there is a space for cross-chain native applications that are just cross-chain from day one. Like it's not Users shouldn't necessarily even need to think like, okay, well, I'm using the Arbitrum version of this application, or I'm using I'm using Polygon, I'm using Aave on Arbitrum, I'm using Aave on Polygon, I'm using Aave on Avalanche. They should just be like, I'm using Aave and I'm sourcing liquidity from wherever it's cheapest, and I'm able to exit to wherever it's cheapest if I want to. And I think that's kind of what we're looking for people to build on top of Connext. Is like, we're, unlike most of the other interoperability systems, we're developer facing. We are trying to get people to build new kinds of like cross-chain products on top of Connext, and we think that those things are going to be like the big winners of DeFi in the next few years. We think that in addition to those kinds of cross-chain products, like, of course, I mentioned that like we're not as generalizable, but because of the way that Connext works right now, because of the way that NXTP works, you can come and build like new kinds of protocols on top of us as well. And those protocols can be to do like more generalized communication. So we're already speaking to a couple of teams that are doing that to be able to like plug in like rollup bridges into NXTP. So you can have like a NXTP connection to another chain, and then you can upgrade that connection in the same way that you upgrade like a TCP connection to like HTTP. You can upgrade that connection to something that's like higher fidelity. We think that there's this like new kind of like protocol stack that will also be built on top of Connext that allows you to like transfer more cheaply, that like breaks up individual transfers into many small transfers in the same way that TCP breaks up like larger packets into smaller packets, and allows you to do this like higher fidelity communication that enables use cases like YouTube that were just like completely unfathomable to people in the early days of internet. Oh, you're muted. Felix, you're muted.
Yeah, sorry, that was like not perfect for me. Yeah, I think we're about to wrap it up again, and I just wanted to ask like one last question more on kind of taking it back a little bit to the user experience of someone interacting with Connext right now. So you're saying, right, like liquidity can be sourced from anywhere. Let's say I'm going on a Dapps side like Aave or something. Mm-hmm. Is there like some Connext plugin that is in there on the Dapps side, or am I as a user even seeing it, or like how does it actually look? Does the Dapp have to integrate with you, or how does that work? Maybe.
Yeah, exactly. We'd be integrating with the Dapps themselves, and like the ideal case is that the user doesn't. Ideally, I would like to live in a world where like the user doesn't even need to know that Connext exists. They just start using this like multi-chain ecosystem. They don't even need to know what chain they're on either. But yeah, at the moment, the way that it would work is that like Dapps like Aave would like integrate Connext as a part of their experience. And a good example, so a really good tangible example, for instance, is like Lifinance. They're building like a bridge aggregator, but in addition to that, they're also working with us on building basically like a cross-chain DEX aggregation. And this is like a really powerful thing, because like the prices of these assets on different chains is actually completely different. And it's like pretty interesting to see that you can, if you really just want to trade into an asset and like you don't really care what chain you're on, you can get like incredibly good prices. And the way that Lifinance does this is like they basically like plug into some aggregator or some exchange, like say Uniswap or One Inch, for instance, on chain A. And then you make a swap from like shitcoin to USDC on chain A. That then goes into NXTP. And then you go using NXTP, you go to chain B, and then on the other side, you again have like One Inch or Uniswap, and that as a single atomic transaction now swaps back from USDC to another shitcoin. So you're able to go from any asset to any asset on any chain as part of the same flow, as part of the same user experience, without ever just making a single on-chain transaction.
Bloody hell, yeah, it's a new level of crypto madness, that's for sure. Yeah. So Arjun, I think we'll wrap it up now. Thanks so much for your time today. I know you're an incredibly busy man. I mean, you're one of the greats in the crypto ecosystem, that's for sure. It's fantastic to have you on. Maybe it might be a good time to sort of maybe share your own personal details. Where can people find you, and also where might people be able to find Connext to learn more?
Yeah, so we have, I think the best ways to like learn more and keep up with us are our Twitter, so twitter.com/ConnextNetwork. And then you can also join our Discord. We have a really active Discord community, and that's like a lot of where we like talk to people, engage with people. If you have any questions, we're super active there. That is chat.connext.network. And then my personal Twitter is also Arjun Bhuptani. So if you follow me there and like message me there. I'm also super responsive there.
Brilliant. Yeah, thanks so much, Arjun, for coming on the show today. And we hope everyone, enjoyed the show. And looking forward to seeing what comes next for Connext.
Absolutely. Thank you guys so much for having me.
Cheers, Arjun.
Appreciate it.